Design and analysis of chassis of electric solar vehicle. Abstract chassis act as a framework for supporting various parts of a vehicle. It needs to withstand twist, shock, vibration, and other stresses caused due to acceleration, braking, road condition, and shock initiated by other parts of a vehicle. It should carry a maximum load under all operating conditions. This paper depicts the design and scrutiny of the solar-powered car chassis. The investigation has been carried out, considering 3 different grades of SAE Steel grades, AISI. By utilizing data of all loads on in all possible direction are considered for designing an excellent chassis. The design and analysis are done using Solidworks and ANSYS. Keywords: SAE Steel, AISI, chassis, solar-powered car, ANSYS, Solidworks. Introduction. A chassis is an internal component of an automobile that supports almost all parts of an automobile. It is similar to a human skeleton. In recent years the design of chassis is drastically changed. The frame has to withstand shocks, vibrations. The design of the chassis is one of the time-consuming part of designing a vehicle. In today's world, there is great demand and advancements in the field of the automobile industry. The solar-powered vehicle is alternate for fossil fuel-powered vehicles. In today's world, renewable energy sources play a more vital role than ever before. In addition to being clean and inexhaustible, they differ from fossil fuels chiefly in their diversity, potential, and abundance for use anywhere on the planet. With increasing awareness of climate change and environmental pollution, big corporations are investing funds for research in making sustainable energies affordable and feasible. In the last decade, significant technological advancements have been made in the same direction. The world is steering toward a sustainable future. The preliminary design was made with the view of driver ergonomics. The design was made in SolidWorks, and analysis is done with the help of ANSYS 16. Based on the analysis, the modification was done, and the design was finalized. Functions of chassis. To withstand the stresses acting on the car due to the bad road condition. To carry the load of the goods and passengers in the body of the car. To withstand the forces due to the sudden braking or acceleration by the driver. 2. Specification of frame. Based on the rule book considerations, inputs from other subsystems, and mechanical properties of the materials were considered. Hence, the design was finalized based on these parameters and made in SolidWorks. The analysis is done with the help of ANSYS 16. Based on the analysis, the modification was done, and the design was finalized. The material chosen for the chassis frame is AISI 4130 of 1 inch diameter and 1.6 mm thickness based on its tensile strength, cost, density, weldability, bending strength, bending stiffness and 3. Cad Modeling. Utilizing SolidWorks software, a suitable sustainable chassis model after numerous iteration and summary of mesh data. A frame of the automobile assumes the most crucial role in the well-being of a passenger. The frame contains the operator, motor, brake system, steering mechanism, and suspension system. So, the frame must possess adequate strength to protect the passengers in the event of an impact. Static structural analysis is a FEM technique used to examine the response of real structures to internal and external loads. CAE analysis on the frame is performed to evaluate the safety offered by the chassis to drivers in the event of an accident, including rear impact, side impact, and frontal impact. A. Frontal impact analysis. It is the impact wherein there is a possibility of a vehicle crashing into another vehicle head-on during the race. Assumptions and considerations taken for the frontal impact analysis are: the mass of the vehicle with drivers is 154.24 kilograms. Constraints are like the force is applied at the frontmost point in a front impact, and wheels are fixed.